GPS, it's one of those technologies that's just everywhere. It's so deeply woven into our daily lives, we honestly don't even think about it anymore. I mean, we use it for everything, right? From finding a new restaurant to navigating a road trip. But have you ever stopped to wonder how it actually works? What is really happening behind the scenes when you pull up a map on your phone? Well, today, we're going to pull back the curtain and figure it out.
But first, to really get a sense of how important this thing is, let's do a little thought experiment. Imagine, for just 1 hour, 60 minutes, the entire GPS network just blinked out. Poof, gone. What do you think would happen?
The short answer? Pretty much everything would grind to a halt. The entire financial system relies on GPS for hyper-accurate timestamps on transactions, so that would freeze instantly. All airline flights? Grounded. Global shipping containers on boats and trucks? Lost. And maybe scariest of all, emergency services would be crippled. It's kind of crazy how dependent we are on this invisible utility. So yeah, that 1 hour of darkness, it really shows you how this invisible network is literally holding our modern world together. So how does it do it? Let's get into the nuts and bolts.
Okay, first things first, we have to bust the biggest myth right out of the gate. GPS satellites are not tracking you from space. Seriously, your phone isn't sending any signals up to them. It's actually a one-way street. Your phone is just a passive receiver, like a radio, constantly listening for signals that the satellites are broadcasting down to all of us.
So, if your phone is only listening, how in the world does it figure out your exact location? Well, the core idea is a cool concept called trilateration, and the best way to get it is with a super simple analogy. Let's just imagine for a second that you're lost, totally lost, out in the middle of a desert.
Here's how it would work. Someone radios you and says, "Hey, I know you're exactly 100 miles away from City A." Okay, great. That puts you somewhere on a massive circle. Then a second person from City B tells you, "I'm picking you up 50 miles from my location." Now those two circles overlap, and you've narrowed it down to just two possible spots. And then a third signal comes in from City C, and bam, there is only one single point on the map where all three of those circles intersect. That's you. You're found.
So that's the basic idea. But of course, we don't live on a flat map. We live in a 3D world. So instead of using circles from cities on the ground, GPS uses giant spheres from satellites way up in space.
In reality, those flat circles become these huge spheres of possible locations, with a satellite at the center of each one. And with signals from 3 different satellites, those 3 spheres will intersect at exactly 2 points. Now, usually one of those points is way out in space or moving at an impossible speed, so your phone is smart enough to just ignore it. The other point? Well, that's you. Sounds simple enough, right? But wait.
If 3 satellites are really all you need to pinpoint your location on Earth, then why does your phone always say it needs a lock on at least 4 satellites? What is that 4th satellite even doing? This, my friends, is where we get to the real secret sauce of the whole system.
That 4th satellite, its most important job has nothing to do with location. It's all about time. See, to figure out how far away it is, your phone has to measure the time it takes for a signal to travel from the satellite. But to do that accurately, the cheap little quartz clock in your phone has to be perfectly, and I mean perfectly, in sync with the ridiculously precise atomic clocks that are on board every single satellite. That 4th satellite provides the perfect time signal to sync everything up.
And this is where the story gets truly mind-blowing. Because to keep all of those clocks perfectly in sync, the GPS system has to account for physics discovered over a century ago by Albert Einstein. Yes, you heard me right. The theory of relativity is running on your phone every single time you open up a map.
It's actually a cosmic tug-of-war between 2 parts of relativity, and they're pulling in opposite directions. First, you have special relativity. It says that because these satellites are zipping around the Earth at 14,000 kilometers an hour, their clocks actually tick a little bit slower than ours. But then you have general relativity, which says that because the satellites are so far away from Earth's massive gravity well, their clocks actually tick a bit faster.
So let's actually look at the numbers here. Special relativity, the speed factor, slows the satellite clocks down by about 7 microseconds every day. But general relativity, the gravity factor, speeds them up by a whopping 45 microseconds a day, so it's pretty clear which one wins out.
You do the math, and it turns out that every single day, the atomic clocks on those GPS satellites get ahead of our clocks down here on Earth by a grand total of 38 microseconds. A microsecond, by the way, is 1/millionth of a second.
And you might be thinking, okay, 38 millionths of a second, that is an unbelievably small amount of time. Who cares? Why does that tiny number even matter?
Well, it matters a lot, because if engineers didn't build a correction for that tiny 38 microsecond drift into the system, your GPS location would be off by about 10 kilometers every single day. Your trip to the grocery store would put you in the next town over. So yeah, every time you use GPS, you're literally using Einstein's theory of relativity. It's incredible.
So with all that in mind, let's just zoom out for a second and appreciate the sheer scale of this system, this incredible, invisible network of satellites that's constantly blanketing the entire planet.
To make sure that global coverage is available 24/7, the U.S. government maintains a minimum of 24 operational GPS satellites at all times. And there are usually a few more than that up there just floating around as spares, just in case.
This whole constellation orbits at a crazy altitude, 20,000 kilometers up. They're all arranged in this perfect orbital dance, so that no matter where you are standing on the face of the Earth, at any time of day or night, there are at least 4 satellites in the sky above you, ready to send a signal. It's a truly amazing feat of engineering, and it really has become the invisible backbone of our world. So from a simple story about being lost in the desert all the way to Einstein's theories literally warping time in orbit, that's the magic behind GPS. It's an incredible system that most of us just take for granted. Which kind of makes you wonder, what's the next great invisible utility that we won't be able to imagine our lives without?